Nice to meet you all. Thank you so much for inviting me, and thank you, Chuck, for organizing this. And, I want to express my gratitude to DARPA for funding our company. So thank you so much. I'll tell you a few words about myself. I'm originally from Italy. Background is in mechanical engineering. I did an MBA, but started my career in investment banking. I was at JP Morgan in London, fixed income derivatives. Decided then to switch career. Went back to school. I obtained my PhD from MIT, also in mechanical engineering with a focus on biomaterials. I then got the entrepreneurial bug, started my first startup in the field of life sciences, a multiplex platform for detection of microRNA. Company was acquired, and then I went back to entrepreneurship through the MIT network, and I was introduced to the inventors of the technology that you're about to hear. So should I join here, or should we use the slide over there?
You can use this if our her slides.
Okay, perfect. I'll use.
You just tell her next, and
so I
next.
don't join here. Perfect.
Okay.
Perfect.
Just tell her next, and she'll do it.
Okay, perfect. Perfect. So I want to say a few words about the company. So the company is based in Medford, just a few minutes from Boston. It's a spin out of MIT. Inkbit manufactures and designs and sells 3D printers for powering the factories of the future. So we are solving a very big problem, very big and complex problem.
Quick question: does MIT have equity in your company?
They do.
Okay.
So
Just a,
it is true. It is a standard contract. So when you invent something, it is owned by MIT, and we license it exclusively in exchange for a small fraction of equity. So they do have equity. So maybe next slide, please. Oh, thank you. So what is the problem that we are solving? So manufacturing has become very reliant on foreign production, and it's become fragile to supply chain disruptions. Could you go to the next slide? And the other aspect is that we are seeing across many sectors an increased demand for faster innovation in products across many sectors. So I'll tell you a bit about the history of the company, and then I would like to take you into the life of one of our customers, because I think that's the best way to show the power of our technology. So Inkbit was spun out of MIT in 2017, and it was actually thanks to a DARPA grant that we spun out. So without DARPA, our company most likely would not exist. And so thank you so much. I'm very, very grateful to DARPA for catalyzing the birth of this company. So could you please go to the next slide? So what I'm showing here is what's called a warehouse customer center, a company called Ocado. Ocado is actually one of our early investors. See, the movie has stopped for some reason. So Ocado makes very large warehouses where products are stored for shipping to customers. Sorry? Yes, so Ocado is a British company that makes customer fulfillment centers of new generation. They are fully powered by robotics. Let me see if I can decrease the volume. Okay, sorry about that. So actually, I think that's enough. If you want to stop the video, that's actually enough. So thank you, Chelsea. So Ocado makes these very large football field size customer fulfillment centers. They're full of robots. These are thousands of robots that swarm around the grid. They pick products and they bring them to the edges of the center in order to be shipped to customers. So one thing to notice is that the company is always pushing the boundaries of what's possible. On a daily basis, some of these robots smash into each other and they get destroyed. But the company has calculated that it's better to have a few losses every day than to decrease the overall productivity of the center. So all of this has a digital twin. So the company keeps running simulations on a daily basis on what is the most efficient way to do things. One thing to notice in this video is that all these robots are identical. They are all the same. They're manufactured using traditional methods. Could you please go to the next slide?
Is Amazon involved at all? Or?
Amazon is not involved, but Ocado is, in essence, a competitor to Amazon. Next slide, please. Yeah, no, the one before. Could you go to the slide before? Okay, that one, sorry. I cannot control the slide myself, you think?
So we need to go back one slide.
Back one slide, Chelsea.
Meet Ocado's 600 series bot,
Actually, why don't
the
we leave it
world's
here?
lightest and most efficient grocery fulfillment
Ocado
bot. Designed to meet the demands
in our
of every
company
grocery
because it was
mission,
working on a
the
highly
600
secretive
series
project
bot is
that has
energy
been
efficient,
announced 8
high
months ago,
performing,
and that is the
and
announcement.
5 times
So
lighter
essentially,
than our
all
500
the new
series bot,
generations of robots
setting new
will be
benchmarks for
entirely 3D.
flexibility,
And this has a
productivity,
number of
and
advantages
cost.
in terms of efficiency, power consumption, and overall efficiency of the crate. So
We use the
new-
latest
you go to the next
advances in
slide.
topology optimization and additive.
Next slide, please. Perfect. So you see here a product, a robot that looks entirely different from the one that you saw earlier. So this robot comprises hundreds of parts that are all 3D printed. So the company chose to go to 3D printing for a number of reasons, and I'll tell you about them in a minute. Could you go to the next slide?
We're gonna get to the slideshow, right?
Yeah, sure. You're welcome. You're welcome. So this is another example of one of our customers that they make robotic arms. On the left, you see an entirely 3D printed robotic arm. Could you go to the next slide? And of course, this is a very brief presentation, so I'll just highlight what we're doing, and then we can go into the details maybe another time. Once again, I want to thank DARPA because during the performance of our SPR grant, DARPA introduced us to the Air Force. And so the Air Force noticed the power of our technology for what I would call virtual warehousing of spare parts. So the goal is to manufacture on demand in a localized fashion across the various military bases around the world. So 2 of our 3D printers will be shipped to the US Air Force, one next month and the next one in 6 months, one in Texas and one in Maine, Bangor, Maine. So could you go to the next slide, please? So what is it about our technology that enables us to, that allowed us to attract the attention of such prominent customers? So there are 3 aspects that are fundamental. And in general, 3D printing is now seeing a tremendous push from the prototyping shop into the factory floor. For the technology to meet the demand of a manufacturing floor, there are 3 requirements that you see up there. You need accuracy, you need functional materials, and you need scale. You need to be able to produce at speed. Could you go to the next slide? So could you activate the movie, please? It's on the left. If you just click, yeah, perfect. Perfect, thank you, Chelsea. So this is the core of our technology. This is what DARPA funded. It's the idea of powering a 3D printer by machine vision. So for the first time, a 3D printer was enabled to see and correct its own mistakes and learn from them. So in our machine, unlike any other machine, there's a vision system that scans every layer after the position. The machine computes a topographic 2-dimensional map of each layer. So each layer is dynamically generated, taking into account the data from the previous layer. So it's true vision-based feedback control. And this enables us very high accuracy, much higher precision, and printing with production-grade materials. So we are a first of its kind, and it's thanks to DARPA that this technology exists. Next slide, please. We named the technology VCJ, Vision Control Jetting. We have 27 patents and 50 pending. The initial IP is owned by MIT, as you were asking, and the rest were filed by us. Next slide, please. So could you click on the movie? Thank you, Chelsea. Sorry, thank you. So this is a movie of how the printer works. You see 4 modules. Each module is dedicated to one material. So this is a multi-material technology. We can make products comprising soft and rigid parts at the same time. And you see this is the core of the machine. It's a vision system that scans every layer after the position. And as I mentioned earlier, the machine runs in feedback control. So it keeps looking, it keeps learning from its past actions.
The size limitations of what you can print?
The beauty of inkjet is that it's very scalable. So that format was chosen simply as a trade-off between cost and speed. But inkjet is applicable to much bigger printers. If we wanted to make a printer the size of this room, it would definitely be possible.
Are you familiar with a company called Relativity for
Yes,
space
yes,
technology?
yes.
So they came up here around 4 or 5 years ago. They had a Series B where they came up, asked for 75 million. They left the room with 80 million.
Wow.
And then a few weeks later, they were on to the Series C with 200 million.
That's
So
impressive.
the only
Yeah.
problem with Tim Ellis, who's the guy that spoke, he looked like he was 19 years old. He was really accomplished. You know, so
That's awesome.
that's a good example. I think you'd have a lot of success doing that too.
Thank you, thank you, thank you so much.
What's the range of materials you can print?
So that is the biggest and most important challenge that we're facing. So 3D printing so far has used a very narrow set of materials. Because of the vision system, we're now expanding the range of materials. So typically, photopolymer-based 3D printing uses acrylate chemistry, which doesn't really lend itself to production-grade properties. In our printer, we use epoxy, we use thiolene, and we are now developing a new revolutionary chemistry called ROM, ring opening metathesis polymerization, that offers tremendous impact resistance. And it's already been used in the trucking industry, and I believe also for protective equipment against bullets. So it's a new chemistry that we're working on. So the vision system enables printing with a much wider set of materials. And if you are interested as to why, I can explain that to you maybe later. Right now, the price to the customer is about $1 million. It comes with the material card that you'll see in a minute, but it's a very powerful machine. So what really matters to customers is the price per part.
Sure.
Yeah, but it's an expensive machine. At the moment, approximately 3 liters per hour, approximately. So just to give you a visual perspective, imagine you want to make a, I don't know, an inch cube product. You'll be able to make about 1 million a year of those, something like that, with one machine. So could you please go to the next slide?
Can you print solar panels? Seriously.
So actually, why don't I show you the roadmap that I have in mind? It's coming up very soon.
Because you know there's a big project with solar panels on the moon, right?
Yes, yes, yes. So the printer was designed for production, so it's very modular. It's every module is replaceable. Could you please go to the next slide? So this is one of our first customer installations. As you see that the printer is on the left, and on the right you see the materials card. So the materials are in liquid form, and they are turned into solids via UV light. It's not very different from the chemistry that happens when you go to the dentist. So it's photochemistry. And the tanks that contain the materials are about 80 liters each. So the machine is basically set up to run 24/7. Next slide, please. Another unique capability that we have, it's a combination of the prowess of our software team and the capabilities of our technology. We can pack extremely dense builds. This is a world record. It will be announced at the SIGGRAPH conference in California. So this is an extremely dense array of parts. It's about 42% in volume. Next slide, please. The post-processing, this is the elephant in the room that nobody talks about. Post-processing can be very time-consuming, so we made it extremely fast by using wax as support material. Next slide, please. This is a very high-level summary of the competitive landscape. You can find in the market maybe one of these two aspects, but you cannot find both of them, and both of them are required for production. You need very high throughput and you need high accuracy. Additionally, you need multi-material capabilities. Next slide, please. So now I want to touch on a very important point. I'll do it very quickly. Traditionally, 3D printing was used in this way. You make a prototype, you iterate. Once you're happy, you move it to production with a different method. Next slide. What Ocado is showing to the world is something entirely different. So Ocado is experimenting with a new concept in manufacturing that I think will lead the world. There's no reason why the two robots on the right should be identical. So what Ocado is doing is essentially treating hardware development like software. They have different versions, like concurrent versioning system, like Git. So you have different versions of a hardware product in production so that you can see if there are slight variations and what difference they make. Next slide.
So it's analogous to like no code.
Yes, that's right. Yes. So this is the history of the company, but I think I already touched on this earlier. Could you go to the next slide, please?
For this group, if there's funding.
Yeah,
that
that's
you're
what we wanna get
interested
to.
in,
Yeah. So
Maybe
I'll
do
do
that
it in a
now.
second.
Yeah.
So this is the product roadmap that I have in mind. So we are starting on the left, single materials. We're adding multi-material parts. Then I want to add electronics and eventually go into the medical field. So it's a very powerful technology. So I'll just talk quickly about the funding. I've raised so far 53 million from investors. The company employs 50 people, and I'm about to start my Series C round, and I'm targeting around 40 million. 40.
What valuation?
The post-money valuation of the last round was approximately 18 million.
Are you familiar? I'm a shareholder, they're public, but a company called Nano Dimension.
Yes.
Now it's focused, from what I remember, they do the they work with the automotive industry.
Yep.
I think Mercedes is a customer. So how is your process different than, or maybe it isn't, I don't know.
It is very different, but the underlying technology is not too different. They also use inkjet
Right.
because they also agree that inkjet is the most powerful, but they are primarily focused on printing of electronics. We are more broad looking.
Okay.
Yep.
Are you familiar with a company called Creative 3D?
No, I'm not.
Any strategic part?
Yes, one thing to mention is that the way I fundraise for this company, as you know, venture capital is allergic to hard tech. So I raised mostly from strategics at the beginning. I have 3M in the cap table, DSM, we have from the Netherlands, Saint-Gobain from France, we have Ocado from England, we have IMA from Italy. So the initial rounds, the seed and Series A were all strategics. And then I invited venture capital for the Series B. This was led by Phoenix Ventures in California.